Hello learners, my name is VijayShri and I teach physics in the School of Sciences of the Indira Gandhi National Open University. I am a professor of physics here and these days we are busy preparing courses for BSc under the CBCS scheme, and today's session will be on the first course on mechanics, the first semester physics course on mechanics, which our students of BSCG must have received. This is what it looks like. The cover of the course looks like this. If you have received the course material, you will be able to recognize it. And those of you who are not our students can go to our website and look at the material. In this session, I will be referring to various sections of this particular course. This session is particularly on a special unit of this course, which I will be making references to. So our students should be able to follow it readily. For others, you're most welcome to visit our website and have a look at the blocks and units. As I said, this particular session is entitled Newton's Laws of Motion, Basic Concepts. It's a part one of a series of two parts in which we will be taking up Newton's laws of motion and certain basic concepts related to the laws. As I said, this is based on Unit 5 of the course BPHCT 131 entitled Mechanics, which is the first semester course of the program BSc-G of IGNOU. Now, the learning outcomes for that particular unit are mainly explanation of the concepts of force and mass. You should learn very well the concepts of force and mass, which I'll be dealing here, and state and apply Newton's laws of motion. So, after studying the unit, these are the outcomes one expects, and these are the outcomes I will be focusing on in this two-part series on Newton's laws of motion. I would not repeat whatever is written in the units, but I would emphasize the main points that you must remember and internalize, main concepts, the main characteristics that you must remember and internalize. What are those concepts I am dealing with today? First, I take up inertia, then the concept of force, then the concept of inertial frames of reference, and time permitting, the concept of inertial mass. If not, we will go to the next session of this particular topic, Newton's laws of motion. So, all these concepts, inertia, force, inertial frames of reference, inertial mass, involve Newton's laws of motion. So, the first thing you have to do is to learn Newton's laws of motion properly. What is the concept of inertia? Actually, you have been studying Newton's laws of motion right from school physics, and you should be familiar with these concepts. That is why I am going to focus on the main subtle points that you must remember when you explain these concepts. Inertia. It is the tendency of a body or an object to remain at rest, or if it is moving uniformly, that is, if it is moving at a constant velocity, then the tendency to continue moving uniformly, that is, moving at a constant velocity, is inertia. You are familiar with this. Here is an example, a stationary cart and a cart that has been pushed and is moving at a constant velocity. This you have to imagine in your mind. We are usually inert beings, we like to sit at a place and daydream. So the tendency to remain at rest, or if moving uniformly, then to continue moving uniformly, continue moving at a constant velocity. This is inertia. So, where all do you use inertia in your daily life? From the simplest of activities like shaking water off your hands or shaking dust off the carpet, you are using inertia. How do you manage to shake water off your hands or dust off the carpet? Can you explain why by shaking your hands or shaking the carpet you can remove water or dust? Even a dog shakes water off its body because of inertia. What is happening here? The drops of water tend to remain where they are. And therefore, when the dog shakes itself, the drops of water remain where they are. That is, they get off the dog's body. And similarly, they get off our hands, or the dust gets off the carpet. These are the examples you may have studied in your school physics. Now, very important applications of inertia are seen in our daily life. So think about the experiences around you. When you sit in a car, why is it essential to use seat belts? Why do you fall off from a bicycle if it stops suddenly, if you brake suddenly? Why do you need to shake a ketchup bottle to make the sauce flow out? Is there a role of inertia in all these? Let's look at a video. What happens to the passenger who's not wearing a seat belt? The car stops suddenly. The passenger is not wearing a seat belt. What happens? The passenger falls forward. And if the passenger is not wearing a seat belt, he or she is likely to injure himself. This is what happens. And this is totally due to inertia. So watching the video, you would appreciate that the passengers, in fact, not wearing seat belts, tended to keep moving forward even when the car stopped, and they could get hurt. This forward motion of the body was due to inertia. It has a tendency to keep moving. Let me ask you a question now. Which of the following is most likely to happen if you are riding a bicycle and hit a wall suddenly? Give me the answer. Think of the answer. There are three options. Nothing will happen. You will fall forward. You will fall backwards. Whatever the answer, you have to explain why you have given this answer. And remember, you've just watched a video, so you will know, you should know the answer. What will happen if you brake, if you hit a wall while riding the bicycle? Here, the person is driving a car. This person is driving a car and hits the wall, and the person keeps moving due to inertia. The car stops because it hits the wall, but the person is moving forward with the car, and due to inertia, he keeps moving. And so that is why we are advised to wear seat belts while traveling in vehicles wherever seat belts are available. So this is a very important application of inertia. This, I hope, has explained to you, brought to you clearly the meaning of inertia and its importance around us. So many daily experiences I have talked about where we use inertia. The second important concept is that of force, and it follows from the very concept of inertia and Newton's first law of motion. Newton's first law of motion must be very familiar to you, and it is based on the concept of inertia. You know very well the statement of Newton's first law of motion. which is that a body will remain at rest or keep moving with a constant velocity unless a net force is exerted on it. Remember, a body will remain at rest or keep moving with a constant velocity unless a net force is exerted on it. So this is where we get the concept of force in our discussion. By implication, Newton's first law tells us that the object's velocity can be changed only if a net force is exerted on it. In other words, when a net force is exerted on an object or a body, it changes the object's velocity, which means that it causes the object to accelerate. Two words I have underlined here, changes, that's the key word. Changes the object's velocity, that is, the object accelerates when a net force is exerted on it. So, you have seen tennis players playing, football players playing, cricket players playing. When they hit a ball, they speed it up or sometimes slow it down or change its direction of motion. In all these cases, the ball is accelerating. There is a change in its velocity, in its magnitude or its direction. So, it means that a net force is being applied to it. This is the key point here. You have learned about the concept of force since your school physics. So, answer the SAQ 1 of Unit 5 or the following questions to judge whether you really know the concept. So, I am asking you, what should be done to make this stationary ball move? Think about the answer, we'll come to it, and in the same breath, think about this question and its answer. If the ball is moving at a constant velocity, is any net force being exerted on it? I have just stated Newton's first law of motion and explained the concept of force, and you should be able to answer the question. When the ball is moving at constant velocity, the net force on it is 0. Remember, if the velocity is constant, an object may be moving and still the net force on it could be 0 if its velocity is constant. This is the catch. This is the catch. This is the concept which generally students don't understand. And when we ask what is the net force being applied on an object moving with constant velocity, they do write some finite force, whereas it is 0. Always remember, if the object is moving with constant velocity, the net force, every time I am saying the net force on it is 0. So, if you want to move a stationary ball from rest, you have to exert a force on it. It could be due to a kick by a player. A football player could kick the ball. A batsman could hit the ball, or a tennis player could hit the ball, or due to handling by a basketball player or some other handball player. So, some force has to be exerted to make the ball move from rest or to change its velocity if it is moving uniformly or moving at a constant velocity. The other thing that you have to understand about forces is that forces are exerted through some agent. They are not exerted on their own, and those could be through contact or there are force fields. In school physics, you already know some of the contact forces, we'll come to it, and some force fields, gravitational field, electromagnetic field. In relation to this, I suggest you study example 5.1 of unit 5 and try to explain in your own words why raindrops fall with a constant velocity after a while of leaving the cloud. What is happening there? Think of this. If the raindrop is moving with a constant velocity, the net force on it is 0. So what are the forces acting on it? What are the forces being exerted on it? It is the force of gravity and an opposite force of air resistance. And when will the net force be 0? When they are equal and opposite, which happens at some point in the falling raindrops lifetime. And at that point, when the net force becomes 0, it falls with a constant velocity, which we call the terminal velocity. Let's look at another situation. When we roll a toy car on a floor or any object, a ball, it stops after a while. What is it that makes it stop? Is there a net force acting on it? Yes. Newton's law tells us yes, there must be, because if it is stopping, its velocity is changing. So, what force is that? Suppose we roll a ball. What makes it stop after a while? The ball will remain at rest unless a net force is applied to it. This is what you have learned in Newton's first law. So, if we set it moving, it will travel forever and ever and never stop unless some net force acts on it. Can we see that force? It might seem to us that the ball slows down and stops and there is no force being exerted on it. We can't see, there is no push, no pull, but there is a force exerted on it that makes it stop. And that is the contact force of friction on the ball. It is friction which makes the ball stop. Slide a book on your table while you're watching the video and think, why does it come to rest after a while? It comes to rest because a force of friction is exerted on it which acts opposite to its direction of motion. If there were no friction, the book or the ball or the car would keep moving forever. So the net outcome from this discussion on the concept of force is what you should remember: whenever an object accelerates, which means speeds up or slows down or its direction of motion changes, remember a net force is being exerted on it. This is something you have to remember, the net force. And if an object moves with a constant velocity, the net force on it is 0. Always remember these two things and then answer the questions. So, I ask you, will every object necessarily remain at rest in the absence of forces? Remember Newton's first law of motion and then try to answer it. And the second question is, a block or a book slides on a table with a constant velocity. Is a constant force acting on it? And let me just give you the answers very quickly. No. Newton's first law tells us what? That every object remains at rest or keeps moving with constant velocity. So necessarily every object need not remain at rest when no net force is acting on it. It could be moving with a constant velocity. Okay, this is one thing you remember. The second question is, a book slides on a table with a constant velocity. Is a constant force acting on it? You will be surprised to know how many students say yes to this. Remember, when an object is moving with a constant velocity, the force on it is 0. And then these are some problems for you to try out. If you haven't understood, watch again and remember these 2 points. Whenever an object accelerates, a net force is being exerted on it. And if the object moves with a constant velocity, the net force on it is 0. Constant velocity, net force 0. This brings us to the third concept, inertial frames of reference. This concept is explained in section 5.2.3 of unit 5 of the course I have referred to, BPHCT 131. What is an inertial frame of reference? By definition, the inertial frame of reference is a frame of reference in which Newton's first law holds. This is what you have studied from your school physics. Okay? So, it means that a frame of reference which is at rest or moving with constant velocity is an inertial frame of reference. A frame of reference at rest or moving with constant velocity is an inertial frame of reference. I will give you some examples of inertial frames of reference. The earth on which we live is an example. Here you see it rotating a bit fast because it's an animation, but do you feel any movement of the earth beneath you? Actually, it's such a slow rotation that for all practical purposes, we can take the earth to be at rest when we are studying objects in motion. So, the best example of an inertial frame of reference is our earth on which we live. Another example of inertial frame of reference is a train moving with constant velocity. With respect to the earth, anything moving with constant velocity is an inertial frame of reference. Now, this is not an inertial frame of reference. Can you tell me why? Remember the concept of circular motion from your school physics? What is happening here? Even if the speed of the car is constant, the direction of its motion is changing every second. So, this car is not traveling at a constant velocity. Remember, this is accelerated motion. This car is accelerating with respect to the earth or any other inertial frame of reference. Any frame of reference attached to this car is called non-inertial frame of reference. Any frame of reference attached to an accelerating body is a non-inertial frame of reference. Any frame attached to the earth, an inertial frame of reference. Any frame of reference moving with constant velocity with respect to an inertial frame of reference is an inertial frame of reference. But the frame of reference attached to an accelerating body is not an inertial frame of reference. This is the third concept you need to understand very thoroughly. You need to be able to solve problems on identifying which frames of reference are inertial and which ones are non-inertial. We will be studying Newtonian mechanics only in inertial frames of reference, but these concepts will be used in later courses on special theory of relativity, for example, and when we actually analyze motion from non-inertial frames of reference. So, let me now quickly revise what we have done in this session. We have studied 4 concepts, 4 things today: inertia, Newton's first law, force, and inertial frame of reference. Just a quick run through. Inertia, tendency of a body to remain at rest, or if moving with constant velocity, then to keep moving with constant velocity or uniformly. Remember, moving uniformly means moving at constant velocity. You've learned Newton's first law, which gives you an idea of the force. And this is what you need to remember. A net force exerted on an object makes it accelerate. The object speeds up or slows down, or its direction of motion changes when a net force is exerted on it. If an object is at rest or moving with constant velocity, the net force on it is zero. Remember. So, a net force has to be exerted to make a stationary object move or to change its velocity. Lastly, an inertial frame of reference is the frame of reference in which Newton's first law of motion holds. So, it is a frame of reference which is at rest or moving with constant velocity. Like this car here, moving with constant velocity is an inertial frame of reference. So this, learners, was the first part of our session on Newton's laws of motion, basic concepts. We will continue this discussion in the next part, and we will take up Newton's second and third laws of motion and the concepts of inertial mass, action and reaction forces, and again I will discuss the subtle nuances of these concepts. Till then, goodbye and happy studying to you.